Starting.
All right, this is for you, Haley and Kevin, and we are just finishing up our test, and we have about 15 minutes of new stuff. Got it.
Thank you.
My second retrieve from today. All right, so to start out, I want you to read, since this is all fresh in your mind, this is going to come rushing out. I need to know the mean of p hat. So someone who's not on the p hat team over here, what is the mean of p hat, Dan?
The mean of p hat
Yes.
is p.
All right. All right, someone who's not on the p hat team, give me the standard deviation. Maddie?
Standard deviation is square root of wait, p times 1 minus p over n.
Okay, and those were on your formula sheet as well. So if you've forgotten, they were there. Now over here, someone who's not on X bar team, mean of X bar, Bree?
Mu.
All right. And the standard deviation of X bar, Andrew?
I'm on
Oh, you're on that team, Shannon?
It's the standard deviation over the square root of n.
Okay, good. See how easy that chapter was? All right, now, I know they do ask some bratty questions, but they ask some straightforward ones as well. All right, well, it turns out in I think you knew this as we were doing chapter 7, there's some stuff up there that is not realistic. Can you point to what I'm saying? What is not realistic about this information? Something about this?
Yeah, you don't always know
Right.
what that is.
And this,
Yeah,
You don't
P.
always know that.
and this. So, like, why are you taking samples if you already know the whole population
Right.
mean? You already know the standard deviation, and you already know the proportion for the whole population. Well, if you already know the parameters, why are you fooling around with statistics? So, you were in a training ground, and I actually told you that while you were there. You needed to know how all that worked and how it related, but today we're going to enter a world where we don't really know the mean of the population, the parameters, p, and the standard deviation. So, what proportions of students at Belmont binge drink? So all right, let's say, when I say binge drink, if they even binge drunk, is that a word?
Yeah.
Drank?
Right.
If they ever have.
How do you know the terminology, Morgan?
If they have partaken in binge activities with drinking, so I don't have to say drink or drunk, because I don't know which is correct, I want to know what percentage of them. They've even partaken one time. So what proportion of the students at Belmont binge drink? Well, we took a random sample because we couldn't get to every single person.
Sure.
So we took a random sample, and we are going to use the statistic from that random sample to find p. So say one sample said, so we'll say binge at Belmont. Let's say one sample we took, the p hat, the proportion was, say, it was 0.09. These are not real numbers, Morgan, so I don't know. Hopefully it's a lot lower than that. All right, 0.09.
Yeah.
Horrible.
Now,
Look,
if
I want to show you what I
that's
drew.
pretty
I drew this. And you drew something.
If I go and take another
No,
sample, will I likely get 0.09? Will I get the same number in another sample?
No.
Probably not. So let's say we go out the next time and it's a little more
That's gonna be like a
reasonable
meme one day.
at 0.05.
Like troll face.
So
But,
Pretty
like,
good too.
what
But
we're
like-
going to do is we're
Those would be
going
on
to
Ocean
do
City
this.
t-shirts.
We're going to look at our samples and
What's
we're
the
going to
caption?
make a probability from them to express the strength of our conclusion. So we're going to use probability to express the strength of our conclusions. And we're going to do this by using confidence intervals. So today our goal is to
Making another
find
steam.
a confidence interval.
That's so weird.
So a confidence interval will entertain us until the bell entertains us even more. All right.
Amen.
To find a confidence interval, we're going to start with a point estimator. Everyone knows that, walking down the hall. Start with a point estimator. A point estimator is our best guess. So that's what a point estimator is. But we're all going to get the same best guess. Our best
Best?
guess.
Bet
Best guess. Can't do it.
as best guessed.
Our best
It's not done
guess
yet.
is going
Oh my
to
gosh, it's another
be
spoon.
found
Spoon.
from what we've learned in the
Just
previous
click.
chapter.
Spoon number 2.
So for mu, if we're guessing the mean of a population, and we took a sample, guess what our best guess is going to be. See, we're
The
going,
mean of the population.
well, that's what we're guessing. For mean, we're trying our best guess for the mean of the whole
try, Miss
population.
Binge.
Remember, we've taken, we'll say, one sample,
The mean of the sample.
which is called,
The
Mean.
what's the mean of the sample? What's the symbol for that?
X bar.
Very
Sorry,
good.
I don't know what I'm
Okay.
talking about.
All right, so for mu, our best guess is going to be X bar, because we're not going to go to every person at Belmont, but we are going to go to a sample at Belmont. And, well, this one was a proportion, so we have to ask them, what can we ask them about? How many hours do you study a night? So we're not going to go to everybody at Belmont, we're just going to go to a sample. And we're going to use the mean of that sample, X bar, to be our best guess for the whole population. But we're not done yet. That's the beginning step of a confidence interval. Start with the best guess point estimator for the parameter. What's our best guess going to be? Anyone? Remember, a parameter is for the whole population. So back to the binge drinking. For the whole population, what's our best guess?
You can label it with
We have. So we're going the opposite way. And we're using the sample to estimate the actual parameter for the whole population. So that's step one. So start with a point estimator. Step two, to finish your confidence interval, we are going to, say we look at p hat. Will you think that will be the exact true parameter of p? No, probably will not. We've asked that question a million times. I can hear it in your answer. So take another sample of the same size and look at p hat the second time. Then you're going to do that. So in theory, if you do that over and over and over and over, you're going to have a sampling distribution for p hats or X bar or any statistic that you're interested in. So in theory, the mean of X bar. So remember, we're going to take many samples and we're going to look at a sampling distribution. Look at a sampling distribution. And a true sampling distribution looks at every possible sample from your population, which is not going to happen. But in theory, the mean of X bar, the mean, if this is our sampling distribution for X bar, in theory, we know the mean of that is mu. So that's not new. We've already studied that. So in theory, the mean of X bar is going to be mu. But we are going to increase, we're going to actually give ourselves a confidence interval around this number, X bar. We know if we took all of them, we would be right at mu, but we can't. So we're just going to take our one measly little sample, X bar, and develop a confidence interval around it. if it was correct, if our X bar was exactly on the mean population, we would be extremely lucky. But
You just
so-
do that for X bar. Look at the sampling distribution, or can you?
yeah,
also-
we're not going to look. I'm going to develop. I'm heading toward a spot, so just wait a
Okay.
second. So we know if we did look at a sampling distribution, which would cause us to look at every possible sample of size n from Belmont, and we're not going to do that. But if we did, we know that the mean of X bar would equal mu exactly if we did everyone. So now we don't really know if our X bar is at the mean. So let's go back to chapter 1 or 2, where I stood here and I barked at you, 95. And what did you all say?
Oh shoot.
And then what did
0.87
you
or
all
something.
say?
Oh yeah.
93 maybe?
68, 95, 99.7.
What was it, Maggie?
Oh, that sounds good.
68, 95, 99.7.
95, 68. That's right. I started.
How
off
did you
wrong.
remember
68,
that?
95, 99.7. Now, do anyone recall what they were?
Yes,
The difference,
yeah.
so
The
Standard deviation.
1 standard deviation,
Area
2
under
standard
the
deviations,
curve.
3 standard
The
deviations.
probability for that area to.
Right, so I heard a whole bunch of stuff together, and here's what I gleaned from it. If you go out 1 standard deviation from the mean in both sides,
Yeah.
you're at 68%. And if you go out 2 standard deviations from the mean, you are at 95%.
Yeah.
And I won't write the next one, but if you do go out 3 standard deviations from both sides, you're almost at 100, 99.7%. So, what we're going to do in order to be sure that our sample X bar captures the mean, the true mean, we are going to use that in backwards as well. So we're going to take our point estimator, which is X bar or P hat. We'll use P hat because we started with the binge drinking here. So we are going to take P hat equals 0.09. We're almost up to 10% binge drinking. And we are going to go out from that number 1 standard deviation this way and 1 standard deviation that way. So we're going to still be in La La Land because guess what? We're going to be given the standard deviation. Does that make sense? But if we're looking for the mean of a population, how are we going to have the standard deviation for the population? In real life, we're not. So you're on a journey. You're getting closer and closer as we go down each chapter to real life. But for now, you are going to know the standard deviation. So we're going to take the mean of X bar, which for our purposes, we're going to take X bar. Let's say the standard deviation for this particular example is 0.001. So therefore, we're going to take the mean, or we're going to take the
Somebody's getting
P
an early start on
hat,
lunch.
and P hat for this example is 0.09, and we're going to
Put
go
that on the video.
up from it, up
not
and
doing
down
I'm
0.001.
not.
So from
I
0.09, we're going to go up 0.001. That'll get us up to 0.091, and we're going to go down. And what's 0.090 minus 0.001?
0.089.
Thank you. So we're going to put a confidence interval around our, we said this was P hat, or we said this is the proportion. So we took the binge drinkers and we are going to say our sample gave us 0.09. We're going to go up 1 standard deviation from it and down 1 standard deviation. And that would give us how much confidence in our answer?
95%.
No, 1, 1, go up 1.
Sorry, Miss Bell.
68%,
Oh,
right?
okay.
So we would be 68%
Wasn't my
confident
idea.
that
Wasn't
the
mine either.
true proportion for this binge drinking is in that interval. But 68 isn't a really good percentage. So let's go up 2 standard deviations in both directions. So would you calculate that for me? We're going to go up, instead of 1 standard deviation, we're going up from the number 0.09 for binge drinking. So if we go up 2 standard deviations, instead of 0.001, we'd have 0.002. So 0.002, so we can go, the higher limit would be 0.002. And the other one on the other side would be 0.00.
No, just one.
0.088?
Yeah.
Okay. All right, so we said we are 95% confident that this interval right here, this one that I drew right here, captures the true parameter. All right, so we're going to take our p hat 0.09. We're going to go up 2 standard deviations and down 2 standard deviations, and we are confident that that captures the true parameter 95% of the time. Will it always? There's that 5% chance that it won't. And tomorrow we're going to actually evaluate that. We're going to actually evaluate this method. We'll do some of these so you can see them. This is theory, pretty much theory. We put some numbers in, but tomorrow we'll go through that. And there's not enough, we haven't gone over enough problems to do any homework on that, but we'll do our typical AP work, sorry. So go back to chapter 7. Actually, let's hold that because some of you are still taking the test.
Yay!
All right. When we finish some tests, we'll go back and grab some AP work. So we'll go back and grab some AP practice on chapter 7. All right. So till we meet again, we'll take a few minutes tomorrow to finish up the test. If you can't get to it, do you have any studies today?
Yes. Your dad.
We do have some.